Hi, this is Peter with CalcBook, and today we're going to be looking at a timber floor joist design, and we're going to be using sawn lumber for this. So just a quick recap for sawn lumber design or timber design, right? We are using the National Design Specification, or also known as the NDS, which has two parts to it, the specification and also the supplement. So in the specification, that has our design procedure, capacity equations, and our sort of general adjustment factors. It also describes or lays out the equations and calculations for flexure, shear, deflection, compression, and then also combined loading. The supplement gives us the information for the specific species type and the corresponding design values, the reference design values for bending, shear, compression, and that sort of thing. So for floor joist design, we are interested in flexure, shear, and deflection. So we'll be using, section 3.3, 3.4, and 3.5, and we'll be calculating that in accordance with the NDS 2018. So let's take a look at our problem statement. We have we're looking at sort of like an elevated storage area, So we have this lofted area with some 2x6 joists at 16 inches on center. We are going to be using Douglas fir larch species type. We have a 15 PSF dead load and a 20 PSF live load. And we'll be using ASD design for this. So let's go ahead and open up CalcBook and we'll get started on the design. All right, we've got CalcBook open now, so we're going to take a look into our NDS 2018 design module. Click on our member design, and then for the joist, we're going to want to look at strong axis flexure and then strong axis shear, and the deflection will come up automatically for us. So we start looking at our inputs here on the left side. We're going to leave the beam analysis, We want to use our beam loading tool, and we'll go ahead and use the ASC7 load combinations. We have sawn lumber, which we said in the problem statement, and then we want to change this to a visually graded dimension lumber. And our species we said is going to be Douglas fir larch. And for the grade, it was not defined in the problem statement, but we're going to pick sort of middle of the road, number 2. It's a pretty readily available grade, and if we need to increase to number 1 or select structural, we can do that as we get into the design. And then we said we are going to be designing a 2x6. And the other thing we need to do here before we start with our adjustment factors is go up to our settings and change this to ASD and then click confirm. So now we want to update our load duration factor, We've done this before. We're considering live load, so we're going to go with a load duration of 1.0. Our moisture content is less than 19%. No temperature condition issues. It's not in size, This is not pressure treated. And then we are repetitive, So for lumber that's spaced not greater than 24 inches on center and has some sort of diaphragm or load distributing element on top, we can consider this repetitive member factor of 1.15. So we'll go ahead and check this box, and that will automatically apply the appropriate repetitive member factor. Okay, we click into our beam loading, We have a 11-foot long beam. For the shear analysis, we're going to want to look at the beginning and the end, so we'll just put 0 there because that's where we know the maximum shear is going to be. For the moment, it's going to be 5.5 feet in the middle, and then same for deflection will be 5.5 feet. And then we can go ahead and enter in our dead load, So we said we had a area load of 15 PSF dead, which converts to a 20 PLF distributed load, so 0.02 kip per feet. And then for live load, we said we had a 20 PSF area load, so that converts at 16-inch spacing to a 26.67 distributed load, so 0.0267, and click Save. And we can go ahead and just toggle over to our dead plus live here, look at our shear and moment diagrams and deflection diagram. And now that we've got that all set, we can click over to deflection. And the only thing we need to update here is our modification factor for creep or long-term deflection. So this K sub CR, we have this amplification for long-term deflection for our dead loads. So for seasoned lumber, which is what we have, we can use a 1.5 factor. So we'll go ahead and change this to 1.5. And it looks like we're slightly over here for deflection, so let's leave that as is, and then we can come back and update the member size once we've looked at the other design checks. So let's go ahead and open up our Flexure Design. And for our bracing configuration, right, since we have plywood over the top of this, right, we are basically going to be fully braced, so we can just toggle that over, and that makes our effective length basically 0. So we can start stepping through our calculations here. At the moment, demand's already brought over from our beam loading. So we have a strong axis bending stress of just over 1100 psi, 1164. And then we start looking at our capacities, right? We have our load duration of 1, right? Wet service, we said we have a less than 19%, so that's going to be 1. Same with temperature factor. Our size factor, right, we do have to update this for a 2x6, number 2. So that means we have a C sub F of 1.3. Flat use, right, this is vertical strong axis bending, so that's 1. No incising, so that's 1. And then here's our repetitive member factor of 1.15. For beam stability, right, we said we are fully braced, so that's just going to be a 1. So when we add that all up, we multiply all of our factors together, right, we get a capacity of 1345 psi and a DC ratio of 0.87. So for bending, we are okay. So we have to shear design for our strong axis, right? No additional inputs needed. It's automatically taking our shear from the end of the beam. So we have about 50 psi of shear demand. And all of our factors here, we get a capacity of about 180 psi. So DC ratio of 0.27, so we're fine there. So the only thing we really have to update here is our deflection, right? We're about 7% over capacity. So if we go back and look at our options here, we could probably just go up to a number 1, reselect our 2x6, then we can toggle over to deflection. And that we're about 1% still over, so we can just go up, we'll just do a select structural, that way we know we'll be good, and we'll toggle back to a 2x6. And we are good now. So 0.9, we can double check our flexure and our shear, and we are good on both those. So that is a floor joist design using CalcBook. We hope you enjoyed the video. If you have comments or suggestions for other designs, please let us know in the comments below, and we'll see you next time.